All right, folks, welcome back to Module 2. We're talking about the fundamentals of statistics here, and we are going to be looking at various scales of measurement. So you heard the term measurement happen, many times already at this point in the class, and you're going to hear it plenty more, because the idea of measurement is essential to a lot of what we're doing, especially with those operational definitions where we're trying to measure things that are very difficult to pin down sometimes. So research is all about measuring these variables, sometimes manipulating them, but always measuring them. But different variables will sometimes provide different values. There are different possible scores based on the type of variable you're looking at. For example, if I ask you what country you're born in, you're going to give me the name of a country. It's not going to be a number. There's no such thing as having more or less or being higher or lower on it. There's just different categories. Those are our scores. But if I ask you how many pounds you weigh, whether you're honest with me or not, you're going to give me a number. And that number reflects a quantity of that variable, whether you have more or less of that weight, whether you're higher or lower in terms of your weight. So different kinds of dimensions, different things we can do with those types of responses. Or sometimes we can take the same variables and the way that we choose to measure them can create different values. Let's say that the variable I wanted to measure was how much students liked statistics classes. Let's say I measured it by a 1 to 10 rating of liking. 1 is you hate it, 10 is you love it, everything else is in between. Or let's say that I measure it by having people rank their courses and seeing if statistics is the highest, the lowest, or somewhere in the middle. Notice that both of those will give me different types of information. With the first approach, I'm going to get a number that reflects a quantity of the variable. And with the second, I'm going to get kind of its relative placement compared to other courses the students are taking. Both of them will tell me something about how much people like it, but the information that they give me and what I can do with it is going to differ based on those different approaches. So those different forms of measurements are called scales. The scale, and you can think of just a regular old bathroom scale that measures weight. It's the same sort of thing. A scale is a means of measuring a variable. So different forms of measurement can fall into different categories on some important scalar dimensions. Different scales provide different forms of information, and they influence how we can assess the data, how we can make sense of it. So there are two key dimensions of scales. And the first one we're going to talk about has to do with how scores can be organized, if they can be put in a meaningful order or not, and how much information we get. I was always taught to remember this by the acronym NOIR, which is just French for dark, and it's just the first letters of the names of each one of those scales. So along our NOIR dimension, the very simplest type of scale that gives us the least amount of information is what's called a nominal scale. Nominal just means names, and the reason why it's called a nominal scale is usually your values on a nominal scale are just the names of categories, like what country did you grow up in. Those categories can't really be placed in any meaningful order. You could do something like alphabetize it, but that doesn't really mean anything in terms of how much of the variable there is. You can't talk about having more or less of the variable or being higher or lower on that dimension. So when you measure people's biological sex or their political affiliation, you're going to get categories. You can't talk about having more or less political affiliation or being higher or lower on it. There's not a quantity element there. Sometimes in research we add numerical codings onto that. It's called dummy coding, but we do it for simplicity's sake, just to make analyses easier. When I code males as having a score of 1 and females as having a score of 2, it doesn't mean I'm saying that females are higher on that variable than males are. It just is for convenience's sake. So nominal scales don't tell us a lot of information. There's not a lot we can do with them. The next, slightly more sophisticated scale is an ordinal scale. Sometimes people will call it a rank order scale. Here, we can order people's scores in a meaningful way, and they reflect being higher or lower on the variable, perhaps doing better or worse. So, for example, if I know what position you finish in a race, that's an ordinal measure. I know if you were first, second, third, fourth, 28th, any other score. If I know your class rank, that gives me a little bit of information. I know someone with a class rank of number 4 did better than someone with a class rank of number 14. So now I can put them in a meaningful order. Here's what I can't do. I can't tell how far apart those ranks are. If one person finishes first in a race and another person finishes second, I don't know if they finished a half a second apart or a half an hour apart. I just know which one did better and do not know how far apart they are in terms of that underlying variable. Same thing with class rank as we see here. We don't know if someone who's first in their class is just a tiny bit above second place or if they're very far above second place. First, second, and third, in this case first and second are very close together. Second and third are much farther apart. If all we knew is the ranking, we wouldn't have any idea. We would just say these are each one rank apart and have no sense of how much separated them. So we now can put things into meaningful order. We still don't know how much the actual variable we're trying to measure is changing. We just know who's higher or lower, better or worse. So the I in our noir mnemonic is called an interval scale, sometimes called an equal interval scale. Here, basically, we have a scale where an equal change in the score reflects an equal difference in the underlying variable. What that means is that if you are 2 points apart on an interval scale, it doesn't matter if you're increasing from 0 to 2 or if you're increasing from 1,000,000 to 1,000,002, the underlying variable is changing by the same amount. That 2-point difference reflects a consistent change in the underlying variable. Remember, every time you go up a rank in a class ranking, you don't know if you're jumping by 100th of a GPA point or an entire GPA point. You don't have that information. In the interval scale, you do. I know that, say, when it goes up 2 degrees on the thermometer, that reflects an equal change in the amount of heat that's present, no matter where that 2-degree change happens. Most psych variables are assumed to follow an interval scale. If your self-esteem score on some questionnaire goes up by a point, that's seen as reflecting the same increase in your underlying self-esteem, no matter where it takes place in the range of possible scores. So most psych variables we at least assume are interval scales. Very hard to confirm if they are, but we assume it. So again, that temperature example, a 10-degree increase in temperature reflects exactly the same change in heat, no matter where in the range of temperatures it takes place. An increase from 40 to 50 degrees is exactly the same change in temperature as between 90 and 100 degrees. That 10-degree difference reflects the same change in that underlying variable of heat. We're going to mostly be working with interval scales this semester, but we will see some ratio scales. Ratio scales are exactly the same as interval scales, but they have what's called a true 0 point. A true 0 point means that it's possible to score a 0 on the variable. That's the absolute minimum that you can score, and it reflects a complete and total absence of the variable. It's impossible for 2 people with scores of 0 to differ on that underlying variable. Talk about the implications of that in a little while. But what this lets us do, like it says in the name, is calculate ratios. For example, time is a ratio scale. Taking 10 minutes to do something is exactly twice as long as taking 5 minutes to do something. With an interval scale, that's not true. Even though 80 degrees Fahrenheit is double 40 degrees Fahrenheit numerically, it doesn't reflect a doubling of heat. So that true 0 point lets us calculate those ratios and talk about being twice as high, 3 times as high, a quarter the size in terms of that underlying variable. Here's a good rule of thumb. Anything that's a psychological variable, that's about people's beliefs or behaviors or thinking, isn't going to be a ratio scale. What are ratio scales are basic physical measurements like distance, time, height, weight, that sort of stuff. By the way, Fahrenheit is not a ratio scale, it's an interval scale. Do you know what temperature scale does have a true 0 point? Some of you would be saying it's degrees Kelvin. Kelvin has a true 0 point. It's absolute 0. It's a total absence of molecular movement. It's impossible to have less heat than absolute 0 on a Kelvin scale. So that Kelvin scale is a ratio scale. Fahrenheit and Celsius are not. Kelvin has a true 0 point. So this is our for future service. Again, this is stuff that's going to be very important later on, but isn't that important right now. So most of the tests that we're going to learn, those tests of statistical significance, they require our DV be at least an interval scale. Usually it just means it's just an interval scale, but it can be a ratio scale as well. If you have a different type of scale, there are tests that you can run. We might talk about those at the very end of the course, but they are a lot less common. And again, almost everything in psychology, the dependent variables are assumed to be interval scales. Independent variables and quasi-IVs often are nominal or ordinal. That doesn't affect things. It's the DV that's important here. We have to have at least an interval scale on that DV to be able to assess it. So remember that study we talked about where we compared celebrities to MBA students to school teachers? We had a status variable there. Notice it was nominal. There's no higher or lower on that variable. It's just categorical. If we give participants information that's true or false, that would be nominal as well. That might be something we manipulate. So that's one dimension. The second dimension of measurement has to do with what sort of scores that we get. With discrete scales, the only scores, the only values, the only possible scores are either whole numbers or separate categories. It's usually a nominal or an ordinal scale. It's impossible to finish in 4.8th place. You could do that on average, but individual scores will always be whole numbers. It is impossible to be born in Texas and a half, or whatever the fractional or decimal equivalent would be for a nominal variable like that. Sometimes we do get discrete data from interval or ratio scales. For example, the number of children a family has. It's not going to be 2.43 or 3.86. That's not how they come out. They come out one at a time. You have none, you have one, you have two, you have three. By the way, the number of children in interval or a ratio scale. Is there a true 0 point? Yes, there is. You can have 0 children and it reflects a total absence of that variable. 4 children is double as many as 2 children, even though it probably feels like about 10 times as many. But again, that is a ratio scale because of that true 0 point. We also see some discrete scales called dichotomous scales. This is when you only have 2 possible scores. So for example, a course could be closed or open, a patient could be dead or alive. There's no real third in between value. A slightly crasser way of saying that, there's an old expression, there's no such thing as being a little bit pregnant. You are or you're not. It is a dichotomous measurement. You're in one category or a second, there's no third value. Continuous scales, on the other hand, can give us data in fractional amounts. There are those in-between decimal scores. For example, your weight. We tend to represent our weight as whole numbers, the number of pounds that you weigh, or kilograms if you grew up anywhere else. But those in-between values are there. 2 people that both weigh 150 pounds don't weigh exactly the same. They're probably at least a fraction of a pound different. And if it's meaningful to us, we can continue to slice those weights up into smaller and smaller fractions. It's basically impossible to fully display a continuous value, so we decide where the meaningful cutoff is and we stop there. The amount of time it takes you to run a race, you might just measure that in minutes or seconds. That might be meaningful to you. In the Olympics, they're going to go at least to hundredths of a second because that's more, because they need to separate those small differences. But there are more decimal places that could be used. They just picked a point to cut it off. So here's the important thing. What makes a variable continuous is if those in-between measurements are possible, even if the actual reported measurements are not. For example, if I ask you how old you are, you're going to give me a whole number that reflects how many years old you are. That sounds like a discrete scale, but it's not. Again, your age is constantly changing. There's lots of in-betweens between the point when you turn 20 and the point when you turn 21. So, in fact, at the end of this video, you're going to be a little bit older than you were at the beginning of it. Don't think too hard about that. That leads to, people going, quitting school and buying a motorcycle. So, again, what makes it continuous is if those in-between values exist, even if we never actually bother to say them like we do with our ages. So, like it says here, you could break someone's age down to the second, the millisecond, you could keep going, as many decimal places as you care to be able to measure it. Or self-esteem, does everyone that scores a 5 on a self-esteem question, do they have exactly the same self-esteem? Almost certainly not. So to review, be familiar with your different scales in terms of what we can do with those scores. And again, the nominal is the least sophisticated, the ratio we can do the most with. Each scale gives us all the information of the less sophisticated scales and extra as well. So we use the most sophisticated scale that we can. And then discrete variables, the only possible scores are whole numbers in individual categories. Continuous variables, there's essentially an infinite number of possible scores. All right, that's the end of this piece. Next up, we're going to start to learn how to organize our information into a very basic form called a frequency table. See you there.